Chapter Electrostatics. What is oxidation? It is defined as a loss of electron, while reduction is defined as a gain of electron. In a reduction reaction, both oxidation and reaction take place simultaneously. What is direct redox reaction? In a direct redox reaction, both oxidation and reaction take place in the same vessel. Chemical energy is converted into heat energy in a direct redox reaction. Indirect redox reaction. In indirect redox reaction, oxidation and reduction take place in different vessels. In an indirect redox reaction, chemical energy is converted into electrical energy. Then device which convert chemical energy into electrical energy is known as electrochemical cell. In an electrochemical cell, first, the half cell in which oxidation takes place is known as oxidation half cell. Second, the half cell in which reduction takes place is known as reduction half cell. Third, oxidation takes place at anode which is negatively charged, and reduction takes place in cathode with it positively charged. Fourth, transfer of electrons takes place from anode to cathode, while electric current flow in the opposite direction. 5. The electrode is made by dipping the metal into the electrolytic solution of its soluble salt. 6. A salt bridge is a U-shaped tube containing an inert electrolyte in agar-agar gelatin salt bridge. A salt bridge maintains electrical neutrality and allows the flow of electric current by completing the electrical circuit. Representation of an electrochemical cell. First, anode is written on the left while the cathode is written on the right. Clear? Second, anode represents the oxidation half cell and is written as metal by metal ion concentration. Okay. Third, cathode represents the reduction half cell and is written as metal ion by metal. Fourth, salt bridge is indicated by flashing double vertical lines between the anode and the cathode. Fifth, electrode potential is the potential difference that develops between the electrode and its electrolyte. The separation of charge at the equilibrium state results in the potential difference between the metal and the solution of its ion. It is the measure of tendency of electrode in half cell to lose or gain electron. Sixth, a standard electrode potential. What means a standard electrode potential? When the concentration of all the specific involved in a half cell is unity, then the electrode potential is known as a standard electrode potential. It is denoted by E theta. According to the present convention, standard reduction potential are known as a standard electrode potential. How many types of electrode potential? There are mainly two types of electrode potential. First, oxidation potential. Second, reduction potential. What means oxidation potential? It is the tendency of an electrode to lose electron to get oxidized. Clear? Second, reduction potential. It is the tendency of an electrode to gain electron or get reduced. Oxidation potential is the reverse of reduction potential. Next point, the electrode having a higher reduction potential have higher tendency or gain electron, and so it's act as a cathode, whereas the electrode having a lower reduction potential act at an anode. Next one, the standard electrode potential of an electrode cannot be measured in isolation. According to the convention, the standard hydrogen electrode is taken as a reference electrode and it is assigned as zero potential at all temperature. Next, what is the reference electrode? A standard column electrode can also be used as a reference electrode. SHE. What means SHE? A standard hydrogen electrode. A standard hydrogen electrode consists of a platinum wire sealed in a glass tube and carrying a platinum foil at one end. The electrode is placed in the beaker containing an aqua solution of an acid having 1 mole concentration of hydrogen ion. Hydrogen gas is 1 bar pressure is continuously worked through the solution of 298 Kelvin. The oxidation or reduction takes place at the platinum foil. The standard hydrogen electrode can act as both anode and cathode. So discuss two relation. If the standard hydrogen electrode acts as anode. Next, if the standard hydrogen electrode acts as cathode. Next one, in the electrochemical series, various elements are arranged as for the standard reduction potential value. A substance with higher reduction potential value means that it is a higher tendency to get reduced, so it's act as a good oxidizing agent. Okay, a substance with lower reduction potential value means that it has a higher tendency to get oxidized, so it's acted good reducing agent. The electrode with a higher reduction potential act as a cathode, while the electrode with a lower tendency potential act as an anode. The potential difference between the two electrodes of a galvanic cell is called cell potential, and it is measured in volt. Galvanic cell. The cell potential is difference between the reduction potential and cathode and anode. E cell equals to E cathode minus E anode. Cell potential is called the electromotive force of the cell EMF. What means EMF? Electromotive force is known as EMF. When no current is drawn through the cell, nurtured studied the variation of electrode potential of an electrode with the temperature and concentration of electrolyte. Nurtured formulated a relationship between the standard and electrode potential E naught and electrode potential A equals to E naught minus 2.303 RT by NF log 1 by M power n equals to E naught minus 0.059 by n log 1 by m and at 298 Kelvin. Electrode potential difference increases with the increases and the concentration of electrolyte and decreases in temperature. Next, a short equation when applied to a cell, it helps calculating the cell potential. यहाँ पे भी डिस्कस किया गया है A is cell equals to A cell naught minus 2.303 RT by NF log anode ion by cathode ion. Okay, at equilibrium cell potential actual become 0. Okay, relationship between equilibrium constant Kc and the standard cell potential EQ cell. The EQ cell is E cell naught equals to 0.059 by n log Kc at 298 Kelvin. Next, work done by the electrochemical cell is equal to the electric radiation Gibbs energy. It is denoted by delta G naught equals to minus an Fe naught cell. The substance which is allow the passes through the electricity through them is known as conductor. What means conductor? The substance which allow the passage of electricity through them are known as conductors. Every conducting material offers some obstruction to the flow of electricity, which is called resistance. It is denoted by R and is measured in ohm. Okay, the resistance of any object is directly proportional to its length L and inversely proportional to its area cross section A. So R equals to rho into L by A, where rho is called a specific resistance or resistivity. The SI unit of a specific resistivity is ohm meter. The inverse of resistance is known as conductance G. Unit of conductance is ohm inverse or mho. It is also expressed in the Siemens, denoted by Siemens. Conductance unit ohm inverse, it is denoted in S, that is Siemens. The inverse of resistivity is known as a conductivity. Okay, it is represented by the symbolic K. The SI unit of conductivity is Siemens inverse. What? It is also expressed in Siemens inverse, SCM inverse. Okay, conductivity equals to conductance multiply cell constant. Next, for measuring the resistance of ionic solution, there are two problems. Firstly, passing direct current change the composition of the solution. Secondly, a solution cannot be connected to the bridge like a metallic wire or a solid conductor. Okay. Conductivity cell. What means conductivity cell? The problem of measuring the resistance of an ionic solution can be solved by using a source of alternating current. And the second problem is resolved by using a specific design vessel called conductivity cell. Now understood? A conductivity cell. A conductivity cell consists of two Pt electrodes coated with the Pt black, then have area of cross section A and are separated by a distance L. Resistance of such a column of solution is given by the equation R equals to rho into L by A. Molar conductivity of a solution. What means molar conductivity of a solution? It is defined as the conducting power of all the ions. Product of dissolved 1 mole of electrolyte is solution. In solution, molar conductivity equals to del M equals to K into 1000 by M, where K conductivity and M is the molarity. Unit of molar conductivity is Siemens a square mole inverse. Okay. Equivalent conductivity. What means equivalent conductivity? It is the conductivity of all the ions produced by dissolving 1 gram equivalent of an electrolyte in solution. Unit of equivalent conductivity is Siemens centimeter square. Equivalent conductivity equals to K into 1000 by N. Coulom's law of independent migration of ions. Why? So according to this law, molar conductivity of an electrolyte at infinite dilution can be expressed as the sum of individual contribution from its individual ions. Okay. If the limiting molar conductivity of the cations is denoted by del naught and that of the ions by del naught, then the limiting molar conductivity of electrolyte is molar conductivity equals to delta naught M equals to U plus delta naught plus U minus delta naught. Okay, where V plus and V minus are the number of cations and anions for formula of electrolyte. Okay, degree of dissociation. I will degree of dissociation. It is the ratio of molar conductivity at a specific concentration C to the molar conductivity at infinite dilution. It is denoted by A. Numerical value A equals to delta Cm divided by delta naught m. Dissociation constant. What means dissociation constant? K equals to C r square by 1 minus A, where Ka is acid dissociation constant, C is concentration of electrolyte, as the degree of ionization, Faraday constant. Faraday constant, it is equal to charge of 1 mole of electrons. It is equal to 96,487 Kelvin, mole in watts, or approximately equal to 96,500 coulomb mole in watts. Faraday's first law of electrolysis. What means Faraday's first law of electrolysis? The amount of substance deposited during electrolysis is directly proportional to the quantity of electricity passed. Faraday's second law. Faraday's second law of electrolysis. It is the same charges passed through different electrolytes. The mass of substance deposited will be proportional to their equivalent weight. Okay. Product of electrolysis. The product of electrolysis depend upon first the nature of electrolyte being electrolyzed and the nature of electrolytes. If electrolytes is inert like platinum or gold, they do not take part in chemical reaction such that they neither lose or gain electrons. Okay, if the electrode are reactive, then they will take part in chemical reaction and product will be different as compared to inert electrode. Okay, next, the electrode potential of oxidizing and reducing a species. Some of the electrochemical process, although feasible, were so in the rate of a lower voltage. This requires extra voltage such that over voltage at which these process will take place. The product of electrolysis is also different in molten state and aqueous solution of the electrolyte. Okay, primary cell. What means primary cell? A primary cell is the cell in which electrical energy is produced by the reaction occurring in the cell. Example: Daniel cell, dry cell, mercury cell. It cannot be recharged. Dry cell, mercury cell, secondary cell. What means secondary cell? Those cells which are used for storing electricity. Example: lead storage, battery, nickel cadmium cell. They can be recharged. Okay, यहाँ पे lead storage battery, nickel cadmium cell. What means nickel cadmium cell? It is another type of secondary cell which has longer life than lead storage but more expensive to manufacture. The overall reaction during discharging COD plus 2 NiOH reaction COD plus 2 NiOH plus H2 liquid form. Fuel cell at an anode पे और at cathode पे. Overall reaction 2H2 plus O2 equals to 2H2O liquid form है. Corrosion, what means corrosion? Oxidation reaction में Fa2 plus 2 electron. Reduction O2 plus 4H equals to 4 in 2H2O. Galvanization, it is a process of converting zinc over iron so as to protect it from rusting. Okay, cathodic protection. Cathodic protection, instead of a coating more reactive metal on iron, the use of such as the metal is made as a superficial anode. Okay,